Good evening, FACC. Good evening, dear colleagues. Great to have you here for the third and also last edition of the Flight Club's 2023. I think the whole year was dominated, of course, by the biggest ramp up in aviation history, and you guys know that much better than I do in the marketing, since you're dealing with that each day. But I think it also was dominated by many other great milestones. And it's my big pleasure to discuss this evening with you guys about one of these great milestones. It's a topic in the area of eVTOLs, as you know. And I think it's for all of us a very inspiring and visionary topic, since it will shape the way how people transport in the future significantly. And I'm very honored we have here one of our most appreciated customers and our most appreciated customer in the area of eVTOLs. Normally you say in the marketing you would like to make your customers to your fans. I don't know if we achieved here in that area, but for sure you made us fans of you guys. And that's not just the only reason why I'm wearing proudly today the Archer t-shirt. But you didn't come to listen to me, so I will stop talking now. And it's a big pleasure to have Tom Muniz here, the CEO of Archer Aviation. Dear Tom, the floor is yours. Thank you.
Good evening. Thank you so much for having me. Tom Muniz, I'm the COO, Archer Aviation. So we're a California-based eVTOL developer, and I'll talk for about 20, 30 minutes, just give you an idea of what the company's doing, what we care about, some of our strategy, some of the things you guys are helping us with, and just how we view this new emerging market and why we're so excited about it. So hopefully you've seen some of the images of our vehicle and what we're making. You all are contributing significantly to that in the form of producing the primary structure for this aircraft that we're building for advanced air mobility. So why does Archer exist? This is why. It's because half the world's citizens, half the world's people live in cities today, and that number's only increasing. So it's not uncommon that people spend 30 minutes, an hour, hour and a half in the car every day, not necessarily because they're traveling long distances, just because congestion on the ground is such a real problem today. And this is true across cities all over the world. So we'll talk later about some of the markets we're focused on, but we really see this as an opportunity to address across the globe over the coming years. So I like to think about this kind of in the broader context, right? How mobility changes the cities that we live in, what they look like, how it shapes our everyday lives. And if you kind of think about that from a historical context, it's really been these revolutions in transportation that have changed how we live our lives. So we were chatting earlier about how if you go back 100 years, when the car was coming to market, how that changed the way cities were shaped and how people spent their time. We think we're on the cusp of the next big change in how people will move around. So if you think about cities today and how they're designed, they're largely two-dimensional flat surfaces, right? They're designed around cars. And that worked great until we ran out of space. And now, as you saw in those earlier videos, these 3D cities that have been built, skyscrapers, et cetera, are still limited to that 2D transportation network. But that doesn't have to be the case, right? If you look at this image of New York City, there's so much space that's not used if you think in 3 dimensions. And so that's really the high-level concept of what we're doing. And focusing on New York, a really great example and one of our first launch routes or markets is essentially taking people on trips that they're already doing, but in a much faster, more efficient, sustainable way. So here comparing a flight in our aircraft from Lower Manhattan to Newark Airport, that trip would take about 9 minutes in an Archer aircraft. If you take it today with a rideshare car, typically an hour, but if there's, say, a traffic accident in a tunnel, could easily take 90 minutes. It's very unpredictable. And again, really there's no reason why we can't serve this route with the vehicle we have today People are already paying significant amounts of money to do these trips. And so a question that is often asked is, well, what's new about technology that's all of a sudden making this possible? Like, we've had helicopters for decades. Why haven't people done this with helicopters? And the short answer is, people have tried. You can actually take a helicopter today on that route. It'll cost you about $200 US. Why don't more people do it? It's for three main reasons. The first is helicopters are extremely expensive. And the reason they're so expensive is because there are so many critical parts. So parts where if they fail, it's a catastrophic event on the aircraft. That same reason, the catastrophic parts, also drives the safety, right? Helicopters have had some significant accidents. There used to be commercial helicopter service in New York back in the 1960s. But the single points of failure really cap how safe these aircraft can be. And then the other really critical thing is the noise. So the helicopter rotors generate tremendous noise, and what that means is if you're a citizen of a city like this, you don't like helicopters because you don't get to use them. You think, oh, they're just for the rich people, and I just have to listen to the noise. It's very annoying. So what's the solution to that? This is Midnight. So this is the aircraft that we are developing. So it will take one pilot flying 4 passengers on routes in and around cities. So we think our average trip will be about 20 miles. The aircraft can fly further than that, but we think most of the demand will be shorter. And you'll be flying 150 miles an hour with point to point, not stuck in traffic, not waiting for traffic getting into a tunnel, anything like that. So you can see in this animation here, there's some very key differences between our aircraft and a helicopter. So if we go back to some of those key features of helicopters, we don't have one main rotor that's a critical point of failure. We've got this very high level of redundancy in the 12 propellers and electric engines on the aircraft. That same level of redundancy goes through all the systems on the aircraft too. So the same way that a commercial airliner today has multiple computers, multiple independent power systems, we have the same features. The other key thing is the noise. So we spin those propellers very slowly. So we keep the tip speeds of the propellers down such that you don't really hear the impulsive noise you associate with helicopters. And it's much more of just the friction of the air that's being driven by the propellers. So really key differentiators. All of this enabled by electrification. So this vehicle is 100% electric. All of the energy is stored on a battery or battery system on board. And all of the propellers are driven by electric motors. So what that does is reduces a lot of the complexity and maintenance cost that you associate with, say, turbine engines, and replaces it with these very reliable, low maintenance cost components. So this is actually not really a new thing. Believe it or not, folks have been working on these sorts of vehicles for about 15 years. I myself started working on these aircraft back in 2009, and the other colleague of mine on the slide here, Jeff Bauer, our chief engineer at Archer, also has been working on this since about the same time frame. So the Midnight aircraft that you are helping to produce for us, that's actually the 8th aircraft that I've been part of leading the projects for. So the difference is today at Archer, we are 100% focused on getting a product to market and making this a real service, a real product that everybody can use. That's our commitment. So we try to avoid science projects. We try and drive everything towards very practical, real applications of the technology, getting products to market. Couple other folks that I want to highlight on our team. The first is a gentleman named Billy Nolan. So he was the previous administrator of the FAA, which is, I'm sure you know, the aviation regulator in the US. So he led the FAA for about a year and a half. He decided to retire and join Archer because he believed not only is this a huge new market that's going to revolutionize aviation, but that Archer was the leading company to go make it happen. And then a couple other interesting folks thinking about kind of the holistic ecosystem. So a gentleman named Nikhil Goyal and another named Mark Moore, They were the co-founders of Uber Elevate. So Uber started to get involved in this maybe 5, 6 years ago, thinking of it not so much from a pure technology or vehicle perspective, but more from how do you build the entire ecosystem to make this happen? Because you need a lot more than just the aircraft. You need the infrastructure, you need the operational plans, you need the booking engine, all the multimodal connections put in place. So those two founded the group at Uber that worked on this. And now Nikhil is our chief commercial officer, and Mark is a trusted advisor of ours. On the technology side, we have chosen a very pragmatic strategy where we're only focused on developing the key differentiating technologies in-house. So here you see a cutaway of our battery pack. So we have large teams in-house that develop the batteries and the electric engines for the aircraft. For most of the other systems on board, we partner with leading companies across the supply base. So same companies that would provide computers to Airbus and Boeing also provide us many of our systems. Our team in California that work on powertrain largely comes from the automotive space. So if you think about the most mature groups out there that have developed products with these electric powertrains, it's companies like Tesla and Rivian, and though nobody really talks about it, Apple has a really big project working on similar things. So we've got a team of about 100 folks that are just focused on engines and batteries. Archer is a publicly listed company in the US, so we've been blessed with very successful fundraising campaigns over the last few years. We've raised close to $1.2 billion, so quite well capitalized to bring our product to market. Really great group of investors that believe in what we're doing. And what's really resonated is, I think, our differentiated approach, which is all focused around commercializing. So we're not out there saying we're going to build the fastest airplane or the longest range airplane. We're out there saying, hey, we've got this really clear business model, and we're taking this very direct path to execute on that business model. So that resonated super strongly with groups that have invested in us. We also have several really strong partners that are very helpful in bringing our product to market. One is United, so they're both a customer and a partner. If you think about the perspective of the airline industry, they're really interested for two reasons. One is sustainability is obviously a huge part of their strategic missions, but it's very challenging with large airliners that are flying across oceans. Tough to make that sustainable. So the near-term approach that they're taking is using aircraft like ours to connect cities that have airports, say outside of the city center, to connect their passengers. So if you think about the New York route from earlier, if you're in Manhattan and you're taking a flight on United across the country or across an ocean, how great would it be to check in downtown? You get on an Archer aircraft, it takes you to your flight, you land on the secure side of the airport, you go straight onto your airplane and continue on your flight. It would be an amazing experience. So that's the goal that we're working with United to put in place. To really make an impact, we also need to think about how we scale up manufacturing. Because if we just make 5 or 10 airplanes, that's great for a few people, but it doesn't really change the world, right? You need to figure out how to make lots and lots of these aircraft. And to be honest, that will take time, but we are starting now to think about that. In the near term, we're building a production facility in the United States, in the state of Georgia, and our partner for that is the automotive group Stellantis. So if you're not familiar, Stellantis is the new name of the merged entity of Fiat Chrysler in the US and Peugeot. So I think they're the 3rd largest auto OEM by revenue today. So we've got a team of Stellantis employees that are embedded with Archer, developing this factory, setting up the production system, getting ready to bring this online. The parts that are being fabricated here will be shipped to this facility, where they'll be integrated and assembled into aircraft that will then be shipped out to these markets that I've talked about. So this facility that you see here is in construction right now. Will be online late next summer, so super exciting. Another partner to mention, this is our newest partner and investor, is Boeing. So Boeing has been very forward-leaning on the autonomy aspect of this market. So again, if you think about really changing the world and scaling this up, what are the big barriers? One is manufacturing. Another is operation of the aircraft. So if you think, say, 5, 10, 15 years into the future, in order for these aircraft to really be effective at scale, there needs to be a lot. And for that to happen, it's not super practical to have that many pilots, right? If you think about having tens of thousands or 100,000 aircraft someday. So Boeing has been very forward-leaning in that area, and we're currently engaged in discussions around how to leverage some of their knowledge and capabilities to incrementally get our piloted aircraft more towards an autonomous aircraft down the road. Another big thing we have going for us is government support in the United States. So a few months ago, we had a group of about 70 representatives from all across the government in the US who were picked by our president to come out to Archer, look at our aircraft. They watched a flight test of one of our aircraft. And the point here is, again, we're putting all the holistic building blocks in place to bring the product to market. So there were groups here from the TSA that does airport security. There are groups here from DOT that do a lot of the higher level regulation. Obviously, lots of folks from the FAA, also some folks from the Department of Defense thinking about potential applications of the technology there. So the great thing here is we've got tremendous support politically across the government to make this happen. And the effect of that is it makes our job easier when we're kind of in the detailed discussions with the FAA, working to bring our product through the certification process, because everybody wants it to happen. It's a big priority for the country, which is fantastic. So what does that look like? Well, here's actually a commercial that United put together. They ran this on the seat-back TVs of every airplane in their fleet over the summer, and it shows what some of these experiences could be like. So 10 minutes, Newark to New York, like we talked about. Other markets we've talked about are Chicago and San Francisco, really great launch markets for United. And here's kind of some high-level timelines. So our goal is to be in commercial service by the end of 2025. And there's multiple pieces that are needed for that. So obviously the aircraft has to be certified. We also need the production certificate to ramp up the manufacturing. In the US, the FAA is working on operational rules for these aircraft that govern things like training and the operational rules for the vehicles. And so that is all targeted to come into place late next year, which is super exciting. And then our plan is to start somewhat modestly. So, we've got piloted aircraft. We'll ramp up training those pilots, building the aircraft. So the idea is to have scaled operations a few years later, say in 2028. And then if you start thinking out to the end of the decade, I think that's where some of the autonomous technology will likely start to come online. So it'll be a super exciting next few years. Like I mentioned before, the goal is to make these vehicles accessible to everybody. So instead of chartering a helicopter for hundreds or thousands of dollars, the goal is for this to be a trip that everybody could take on business or personal trips. So if you look at a helicopter today for comparison, the units here, the vertical scale, that's dollars per passenger seat mile. So if you fly 1 mile in a helicopter, it'll cost you around $10, slightly less. Our goal for entry into service is to be a little more than half of that, so slightly more than $5 per seat mile. So if you think about a 10-mile trip, something like $50. That trip from Newark to Manhattan, something like $80, which is actually about what you would pay today if you got an Uber or a Lyft, rideshare on the ground. If you think about when we increase the utilization and also drive efficiencies through scaling, manufacturing, et cetera, we're very confident the price can come down for consumers. So our goal is to get this ultimately competitive with lowest cost rideshare and ultimately with car ownership. So that'll only happen with very high scales. But if you think about it from a first principles perspective, there really is no reason why ultimately these vehicles couldn't be similar in cost to automotive, right? Today we're only going to produce tens, hundreds a year, but it's all very scalable in time. We were having a discussion earlier about the composite aerostructures manufacturing. That's a really unique challenge, but also I think huge opportunity to leverage some new process technologies there. Think about making aircraft much more like cars are manufactured today. So we're super excited to continue working with your team on that, and also leverage our automotive relationships. So Stellantis actually has a huge effort going on as well. And then the other piece is infrastructure. So we have a team working on the takeoff and landing facilities that these aircraft will use. The plan is to leverage existing heliports wherever possible, but in areas where that's not possible, we're conceptualizing and starting to prototype some modular infrastructure. So what you see here is sort of visualization of a demo vertiport that we are building in California to learn about the operations of these aircraft. So this particular setup would have multiple landing spots and gates, if you will, for us to learn about the high cadence operations and what the right infrastructure would be. And then the way we're constructing all of this is such that it could be repositioned if we learn a particular market is, say, not as good as we had assumed, or other are better or worse. From a market perspective, we're focused on going to market in the US, because that's where we're pursuing certification today. But again, we do think there's huge potential around the world. So we have a large data science team that's analyzing how people move around cities all over the world. So this is just a snapshot of 15 or 20. And in each of those cities, what we can do is, by analyzing the traffic data for where people are moving today, predict what really good routes would be. And so we can then use that to make strategic decisions around, hey, what countries should we consider partnering with if we want to go international? Things like that. Again, a big part of our strategy is to partner with leading companies. So again, I think this is a differentiator for us. The way we're approaching the problem is there's a lot of hard problems to do. We think the right way, or the most likely way to be successful, is by reaching out and partnering with the best companies. Honored to have FACC on this list, along with many other of the leading names in the industry. This is also, I think, a differentiator. Some of the other companies out there, I think, believe they can be smarter or better than other folks that have decades of experience in history. So our core values are to partner, to leverage all the learnings that we can get by partnering with groups like yourselves, but then also work together to innovate, because there's new problems we need to solve here. And so we can't do it just the traditional way. And then the last bit of the puzzle is, okay, what will this look like for me as a user if you jump forward a few years? So we also have a team that's working on the application for this. So the idea is you are in New York and you need to get to the airport or something like this. So you pull up your phone, and the same way in which you would order a ride share, you would order a ride on an Archer. And then it would tell you, okay, great, go to the helipad downtown. Your flight will leave in 20 minutes, and then you're on your way. So that's the vision. And thank you very much for your time. Looking forward to the questions.
Well, thank you. Thank you very much, Tom. Really, really inspiring story you have to share. And when you work for a company called FACC, you're often asked, what's the name standing for? What is behind the name? And also Archer, I think, is quite a name where you think, what's behind the name? So how did you get to choose the name Archer? What's the story?
Sure, yeah, there's a story there. So the founder of Archer, the CEO, his name is Adam Goldstein. So he actually does not have an aviation background. His background is more in finance and other entrepreneurship, startup companies. So when he decided to get involved in this space, he went back to his alma mater, which is the University of Florida, so state of Florida, back in the US. And the main road that runs through that campus is called Archer Road. And so he donated some money and built a laboratory to do some early research before starting the company on Archer Road. So that's the story of Archer.
Wow. Yeah. Amazing. Well, guys, let's go into the panel discussions. And Tom, I kindly ask you to take a seat here. And I call our CEO, Robert Machtlinger, on the stage. Vice President, Engine Nacelles and Urban Air Mobility, Günther Nelböck, VP Operations Area of Engine Nacelles, Günther Merzendorfer, and last but not least, I always call him the Professor, Dr. Peter Glaser, our VP of Engineering. Well, guys, everybody is familiar with the concept of Flight Club. I will not make the same joke as I always do. You know what I mean? Just take out the L. We will go into the panel discussion now, and afterwards we are here. We get to the point. What we're here for is getting you guys involved. You will see now on the screen the access data to slido.com. Log in with the password, and you will decide what things we discuss later on. Meaning, you can either ask by real name or anonymously your questions. And if you don't want to ask some questions, you can even contribute by upvoting questions from other folks. And you will direct me which questions I will ask. So please contribute, please ask a lot of things. Don't be scared about any topic. I was told there is nothing we cannot ask. The question is what answer we will get. And if you don't want to ask, just contribute in upvoting. So Robert, we heard this great story and vision of Archer. What significance does the whole area of urban air has for FACC?
Well, first of all, again, thank you, Tom, for joining us today. Also, Vanina, thank you for coming. Well, we all know we entered this urban air mobility market 5 years ago. So actually 6 years, so it was 2017 when we looked into the market and we said, well, there is something out there, something is developing. And many people that time was asking us, why are you doing it? For what? So aerospace is great. Aerospace is resilient. You have more than 5 billion of backlog. Lean back and enjoy what you have. And we said, no, that's not the DNA of FACC. Because aerospace is a great business. It's good customers, not so many. Very trustful. But if you want to grow faster than the competition, we need to enlarge our portfolio. We need to do something that is innovative, and FACC lives from innovation. So we would not be here today if we would not be innovative, because Austria is a small country, not big in aerospace. So the only reason why customers are seeing us here in Austria is we do things a little bit different than maybe the rest of the world. And by looking into it, we found out, well, 35 years of composite know-how can be contributed to this new way of air mobility. But we also said we can learn from it. You said it, Tom, scalability. You don't talk 100 chipsets a year or 500 or maybe 700. You talk thousands. And if we develop composite technology that is scalable for urban air mobility, we can bring this technology back to our core competence, civil aerospace, and this gives us a tremendous amount of a market, I would say, benefit compared to others who are not doing it. So, coming back to your question, what could it be for us if Archer and our other 3 customers only deliver half of what they're promising in terms of size and value or volume? We talk a couple of 100 million of revenue a year. So just to half of it, what you're telling us, and we are very happy already.
Well, for sure, we're happy to be part of that story. So, Günther, you're part of that story from day one. So please let us know how did the whole cooperation in between Archer and FACC come along.
The starting point was the execution of the strategy 2030 with that extended product portfolio, entering also the urban air mobility market. And it was back in the quarantine times, back in 2021, when we had the first contact. We used a lot of social media, virtual contacts in that time. And that was the starting point. And I can remember it was a contact to you, Vanina, to the CPO of Archer, that we introduced ourselves and tried to get into touch with Archer. Many of the target customers are located in North America, but also many competitors of FACC are located there. So there was an advantage, a disadvantage. Then we followed up with meetings on site there, presenting FACC, our capabilities, our competences, specifically also focused on engineering competences. And I think one of the crucial meetings we had was a visit then later on from an Archer team here at FACC, where we could demonstrate and convince them that there's really a lot of competence available in regard to manufacturing and also engineering at one location. And that was the starting point of everything, and then we could get into more details and work out a contract.
If you have different opinions of what we are talking here, just interrupt us. But since a very strong element of all of this is also the production, Günther, I know that Archer already helped FACC to achieve one of the records in history about, I think, the biggest single component we're making, and correct me if that's wrong. But I think everybody's interested in what actually are we developing and most of all producing for Archer Midnight.
Yeah, we produce the main parts of structure, like the fuselage and the wing. There's the biggest parts as well, so we do all the structure parts.
And where is this happening?
In Plant 4. The initial setup for production and industrialization is in Plant 4 here in Reichersberg. And I have to mention we did all the tooling as well here. And I think that was one of the first achievements right now. The speed and the agility and the targets we achieved with the tooling. Because first of production is always the tooling phase, and I think that the team did a great job.
Well, when I saw it the first time, it really looks amazing. And when you see it put together like we did in Paris Air Show, you just say, wow. So I hope all of you will see it one day. Tom promised me we will get one of these, or we can buy one of these, let's say it like this, in a small scale model to put it also out there. So looking into the audience, who is working on the Archer Midnight project? Just raise your hands. Okay, amazing. I think the rest is still in the factory working, so that's good. Peter, what is the status quo of the engineering work on the Midnight project?
So engineering-wise, we have, as you know, we do two packages. What Günther was just describing is the structures production contract, which Archer engineered in-house. And engineering status is fully released, and we're in the middle of building, have built a few components, and are finalizing those. But we, and frequently overlooked, we also develop and manufacture the interior linings for the cockpit and the cabin. Status for development there is fully developed by FACC. Cockpits fully released and built. The cabin is ready to be released, but been put on hold at the moment just to make sure that once the structure is complete, any last tweaks get still woven in. That's a clever thing to do to avoid any costly tooling changes, and it's a standard way of working. But we're pretty much there just to kick out all the parts.
Tom, one of the core areas of FACC for sure is lightweight construction and lightweight in general. So what role does lightweight play for you guys, for the aircraft, and how heavy is it actually?
Yeah, just like any aircraft, the weight is a huge challenge. So Midnight has a max gross takeoff weight of 6,500 pounds. And obviously every pound that we save goes into increased performance, because then we can have more batteries on the aircraft, or heavier battery, and that translates directly to range. So the biggest technical constraint here is, since it's all battery electric powered, the range is a big challenge. The batteries on the aircraft take up roughly 30% of the total weight. So very significant weight of the aircraft.
Günther, what's the current status?
On plan. We are now building the first chipset. The first chipset is part of the 6 main vehicles which will support the flight test campaign. And we are scheduling for end of January to complete that unit, the first one.
Is this in line with the production schedule, or what is the production
Of
schedule?
course, yeah. We already
Fully aligned.
started T02.
Yeah, many challenges I think ahead of us here over the coming months, but I definitely want to say thank you to the team for the flexibility and working with us as we really develop the aircraft in partnership with you and your team. So I know it makes all of our lives more challenging. It's not a very clean build to print type situation, but I think we'll end up with a great result.
That's maybe also a little bit the differentiator, or differentiator to other programs we are doing. I mean, concurrent engineering, that's not new, if you want so, but that level which is expected from Archer is a different one. Yeah? And we really have to condense everything. We also have to take a certain risk level or an elevated risk level on making decisions in order to condense that development phase. And that's definitely how we are pushing and implementing changes, how we are doing the start of tool manufacturing. That's completely different as we are doing that on commercial airplanes.
Just to chime in there, I think one thing that's also really unique about Archer is we're trying to do things much more quickly in aerospace than is typical. So 4 years ago, Archer had essentially no employees. And so today, in the last less than 4 years, we've ramped up a team. We have about 700 people now at our company. And we've built 2 full-scale flying prototypes, been flying for the last couple of years. Very deeply engaged with the FAA, over 3 years into our certification effort. So much quicker timelines than traditional aerospace. And I think, again, the only way we can do that is by being very pragmatic in our decisions and by partnering and not trying to solve every problem by ourselves.
And by supporting FACC through an on-set team from your side. That's also from the early stage from this project till the completion of the first chipset, we have 2 to 3 people all time on site. So we are really very close connected to Archer, independently that this is a company located in the US.
But that's a good question, actually. I mean, comparing you guys and the whole eVTOL industry, which is very rapid, very fast in delivering, compared to the legacy aviation, which is long term. How about the life cycles of the product? I mean, taking a passenger aircraft, you run it for 30 years or more. What about a Midnight?
Yeah, you mean how long will Midnight last in service? And
for example, are there any calculations on that, or?
Well, we've designed the aircraft to have roughly a 10-year service life, which is much shorter than, say, an airliner. But that's with a lot of assumptions around the operational cadence and how many cycles will be put on the aircraft per day. But then the other piece to keep in mind is the technology is evolving quite rapidly. So if you think 10 years into the future, it seems somewhat unlikely that these exact aircraft will still be economically compelling compared to what the latest technology would be at the time. The other thing we keep in mind is how can we make things modular? So we were talking about the batteries earlier. That's a great example of a system on the aircraft that we could change, say, in service, and through an amended TC incorporate the next generation of battery technology, adding additional capabilities, more range, et cetera. So I think it's likely that this first batch of aircraft will be compelling for many years as we go and develop markets around the world. But then I'm optimistic that if you think out maybe end of the decade, we'll have a lot more exciting new technology coming online that'll drive the prices down, drive the volumes up. Amazing.
And I mean, thinking about life cycles, they're also used to optimize and to improve. And maybe after having version 1.0, you get 2.0 and so on. So what can be optimized in eVTOLs, or maybe even in the Archer Midnight. I'm not sure if I'm asking the wrong question now, but what can be optimized in eVTOLs in the next iteration from an engineering standpoint?
Well, we're trying to bring to the table all the things that come obvious to us, and then we need to focus on the things that we are good at. I mean, we'd never come and say, use those batteries, because we don't know anything about batteries. But what we're great at is affordable, lightweight, and as Tom was just saying, there is no business case without the product being as light as possible, and that beyond what the traditional airliners have been looking for. So on that project, we really get to show going the extra mile in getting grams and pounds out does pay off. But what we bring to the table is that we're not a Formula One team, and they're not a Formula One team. They cannot afford paying bazillions for the last gram. So what we need to always focus is where's the benchmark of what is still affordable, and I think that's what FACC stands for. We are lightweight, and they need lightweight.
I think that was a good point right now, Peter, because we talked today in the morning hours, and you showed this nice chart on how much a passenger might be willing to pay. So we need to lower the cost of production, and good discussion today on how can we qualify new sources. So if we talk to the old these dinosaurial supply chains in aerospace, they are not very agile to change, because they say, here we are, that's what we did for 40 years, and that's the cost. So I think by those business models you are running, we can significantly cut costs by new processes, new materials, new designs actually that work better than what we currently have in aerospace, and we can deep dive into the supply chain and qualify new guys, because some people might be more hungry than the existing ones. So that's a big benefit, and I think urban air mobility like Archer and all the other ones, they are more agile and more open to entertain those kinds of discussions. So it's just a win-win at the end of the day.
Just a reminder for the audience, do not forget to take out your smartphones, open your browsers, go to slido.com, enter the event code, #FlightClub. Everything should be visible here. Start asking your questions or upvoting. We will later on get to them. Günther, looking at production, it's always when I say Günther, nobody knows where I'm looking first. So production, Günther. Are there any special challenges in the production of components?
Yeah, there are some. First of all, the parts are big, they are huge. So we have to take that into consideration when it comes to layouting and then handle all these parts and the toolings. But as well, another thing is, another challenge is we are not in a serial production right now. We started, and that was because I mentioned before that the tooling part. We already showed that we can handle all these challenges coming with an agile project approach, and that's one thing we try to do now as well, to bring together experienced people with the agile mindset, so that we can handle all these challenges which are we have to deal right now, and which will come in the close future, because we are in T01, started T02. But the teams work pretty close together. FACC team, the Archer team, you mentioned it, Günther mentioned it, the Archer guys here. So I think that they do a really good job handle these challenges.
I think there is another aspect in manufacturing. So if you are building rate more than 1,000 a year, this definitely will change the setup of FACC, because we cannot deliver 1,000 fuselages and wings every day across the Atlantic Ocean. So the FACC footprint in terms of setting up facilities in the United States with products like yours, that's an enabler for us. So having larger scale production in the United States, which I think is part of our vision and strategy. So we are strong in Europe. We have something in the United States, but we need to be stronger there. So locally producing for high volume production, I think, is very essential. So it's also changing the landscape of FACC again. Would you like?
When are we going to see the first Midnights flying with FACC components on board? Maybe for testing reasons.
Yeah, so we're flying the first Midnight aircraft today in California, but it's not with your parts. So the first flight will be with a pilot on board. Right now it's targeted for late first half next year, so early summer next year.
Wow. And when are we going into serial production?
25.
25. Amazing. So you spoke a lot about piloting versus autonomous. It's also interesting to look at your relation with Boeing here, considering your background in WISC. So you do believe that from 2030 on, Midnights are going to fly without a pilot?
I think it's really tough to pin down timelines for this, largely because of the regulatory aspect. So today in the US, there's not really a clear path as to how you would certify an autonomous version of the aircraft. It's very clear how we'll certify the piloted version, and that's why we're on the path that we're on. But then I think the other element is, as we were chatting about earlier, it's not like binary, fully autonomous or fully piloted. I think the most likely path is there's going to be increased automation on board the vehicle. So if you think like very bare bones, from day one, the aircraft will have very robust envelope protection. So preventing a pilot from stalling the aircraft, for example, or taking it outside of the known structural flight envelope. That's like a good example of automation for safety. As you think about kind of the years going on, I think likely there'll be more and more of these automated features, such that at some point, timeline's hard to say, hopefully before the end of the decade, more of the standard procedures that a pilot might do would be automated. So the pilot can be more of a supervisor, kind of making sure that the automation is doing what it should, gathering data both for our company as well as for the regulator, getting that confidence put in place such that at some point in the future, an autonomous product or say an aircraft with personnel on the ground that are monitoring would make sense. The other piece though is the customer acceptance. So, some people might be willing to get on a fully autonomous aircraft, but I think from day one that will be quite a challenge. So I think it makes sense to have many years of operational experience, have people get comfortable with the idea, see the value, and then essentially generate the demand that's going to drive the investments needed, the collaboration needed to really get to some much higher scale use of aviation in the future.
Right. And are you also planning to go into operations yourself, or is it always through partnering with United and airlines or other entities?
Yeah, it's a good question. So the business model is a mix of OEM sales as well as operations of the aircraft. And the reason for that is, again, our big strategy is reducing risk to market. So if we were to take on everything ourselves and only be able to generate revenue by operating our aircraft, it would just increase the capital required to really do what we want to do. So by having a select few groups, say United in the US, or we're having a couple conversations with some other large airlines internationally that would buy aircraft directly from us and then collaborate on the operations, we get a chance to generate a lot of early revenue from those aircraft sales, benefit from the sales channels that those airlines have. So say addressing the United customer base directly, taking advantage of the loyalty that those customers have, right? I'm like an airplane geek, so I know what every aircraft is before I get on or when I get on, but most people probably think, oh, it's just a United airplane. I don't really know if it's a Archer or a Boeing or an Airbus, but they just trust the logo. So I think there's a lot of benefit to get from that too. But then if you think long term and this really operating at high scale, the really compelling piece is operating the network and serving people with that full product. And so we were talking about the interiors earlier. Another big focus of our company that I didn't really touch on is we really prioritize thinking about the holistic customer experience. So we don't want the experience of flying on our aircraft to be just a pure financial transaction. You know, you buy a ticket, you save 10 minutes, great. But it would be better if you pay $10, you get this amazing experience that, hey, yeah, you saved 10 minutes, but also it's something that was really compelling, and you're in an aircraft that was beautifully designed, and you're sitting in an interior that has super high craftsmanship and is very unique, and just making the whole experience something that you enjoy doing. I think most people today, when they spend their time commuting, it's just, hey, I have to drive home, or I have to take the train, or have to get on this flight. But if instead it was a moment in your day that you looked forward to, I think there's a huge opportunity there. So we're trying to capitalize on that as well.
This is amazing, and I think you're totally right. Looking back on what aviation once has been, you know, with all its passion and pioneering and heroism, and thinking about the good old Pan Am times in the 60s and 70s, and now it's a commodity for most people, getting from A to B efficiently. And I think the whole eVTOL topic and what you guys are doing is getting a bit back to make flying great again, even though that slogan shouldn't be an analogy to something else. But you know what I mean? Robert, before we go into the audience, what is the vision of FACC when it comes to eVTOLs, advanced air mobility, and especially our partnership with Archer?
Well, I think it's very clear. We want to collaborate with every player, and I think we talked also today in the morning. It will not be hundreds of players in the eVTOL market, so it will be a handful plus minus, and we want to be, as we are with our established customers from A to B to C, whatever we call them, we want to be the most trusted partner to our urban air mobility customers, like Archer hopefully is one, and the other 3 as well, or 4. So we have been very selective with whom we are collaborating. So many people knock on our door and say, hey, would you be interested? And in 90% of the cases we say no. And I think, as you said, Gunther, we have selected our landscape where we say this is the trusted customers we're having, because I think trust is here very important. So you first of all trust us. If you wouldn't trust us, we wouldn't be here. But you're also trusting our customers because aerospace is long-lasting and it's quite intensive in investing, honestly saying. So trust is very important, and that's what we like. So we want to be one of the first one, and that's what we are, and we want to be one of the biggest one, supporting our customers in this new way of mobility.
So now it's time to trust you for asking the right questions and not the wrong ones, since we have our appreciated customers here, but I'm trusting in you. So we start with Bernhard. How do you see the hydrogen fuel cells as option for the future? I think that's directly related to you.
Sure, yeah. That's a great question. So my background is actually in batteries and energy systems, so this is like a topic that's close to my heart, I guess. So fuel cells are challenging for 2 reasons. One is, if you think about the power density, when you think about the entire system, including the storage and the conversion and the whole balance of plant, it's tough to get enough power density to make the vertical takeoff and landing work. So any practical fuel cell solution would need to be essentially a hybrid that had a high power battery on board, as well as a lower power fuel cell for kind of more steady state operations. So if we were trying to design an aircraft with a different specification, say to go 200 miles or something like this, then I think it's an interesting option to consider. The reason we discounted that is, again, we look at everything through the lens of the business case, and we don't see a large demand for those longer routes. We see the biggest demand in these flights, 15, 20, maybe 25 miles, where you're taking a trip that would be an hour or 2 on the ground, and you're doing it in 15 minutes. So in order to do that mission most economically and with the most simple aircraft, the battery electric makes the most sense. We can just charge the aircraft on the ground in between every flight. It's much more straightforward. The other, I think, thing to keep in mind with fuel cells is if you analyze the full efficiency cycle, kind of well to wheel, if you will, there's actually quite a bit of inefficiencies in the process to create the hydrogen or source the hydrogen, and then all the times that it gets converted. It's actually not quite as sustainable of a full cycle. So viewed through that sustainability lens, it's a bit more challenging.
Again, Bernhard, you have a lot of fans. First and second upvote. What challenges do you see? Okay, somebody put away the question while I was reading. What challenges do you see? Again, what is going on here? Directors, please don't let me down now. Otherwise, I need to look on my own mobile phone. What challenges do you see in the transformation of the existing design and manufacturing methods towards high-rate production?
I can share some aspects and ideas from my side. The amazing thing on the UAM project is due to the high rates which are forecast, you have to consider two rates, a low rate, a stable, reliable process and material concept for the early phase to support certification, to reduce the risk levels. But at the same time, you would fail or it's not the appropriate technology for higher rates. And we always see it more or less rates for single aisle. That's the limit for the established technologies. On those OEM projects, you have to start to think and to talk and to make concepts for the high rate technology in an early stage. Also during the meeting today, we talked already what could be an appropriate technology for high rates for Archer. And we conclude it right now. You have to do it step by step. Yeah? We conclude it right now. Now it's the time to support the flight test campaign with components from FACC so that they can get the first milestone with the type certificate. But we also concluded that we have to start to make detailed concepts for that high rate technology somewhere in the second quarter next year. And that's a fascinating thing on this one, because the question was here the challenges, what we see in regard to design, because we have to consider that in an early stage, they are doing the type certificate. To repeat and complete type certificate, to repeat a flight test, a campaign 100%, that's more or less impossible. So you have to very smart think, what are the changes you can implement and what technology supports those changes for the high rate to in order have just moderate additional efforts to later on get also the certification for the high rate. For us, for FACC, I think it's a big chance. All the good things we have in our R&D funnel, all the tests, the demonstrators we have built right now, to bring that also onto a product and into the production at FACC.
But at the end, I think it's three elements. We need new materials that are affordable. That's currently the biggest problem, because we can use different materials and processes. We squeeze out labor, but the additional material cost is pretty much compensating the saving we have on labor hours. So the second thing is we need the manufacturing equipment allowing high rate production in a robotic environment. Well, and then we need, I think, a certification roadmap in order to make it fly.
Yeah, and obviously the other piece is the design is so coupled to the manufacturing process. So we would need to select, okay, which process for which part, and then invest the time to change the designs, etc. So I think it'll happen step by step,
For sure.
over time.
Yeah, I think to add to that what Günther was saying, and we just confirmed, I think we have the benefit that within FACC we have trialed, and not just in R&D, but also for serial production, multiple types of products or production processes that are well scalable. There are others which aren't so well scalable, but looking at that wing, and is most likely a good candidate for RTM or many other processes. But as Robert said, we would have to couple that technologies which scale, which are rateable and automatable, with a material supplier which undermines the pricing of today's aerospace at the same narrow quality of or narrow bandwidth of quality.
Next question from the most well-known colleague in our company with the name Anonymous. Are different configurations planned of Midnight? More, less seats, material transportation? Question mark.
Sure. So the first product is planned to be offered in 2 configurations. So there's 1 pilot seat in the front of the aircraft and 2 rows of 2 seats. And then there's a baggage compartment behind. But there could be some missions where, say, there's lots of luggage, maybe, and you're doing an airport trip, where you would prefer a larger baggage compartment. So we plan to offer a version or be able to fly the aircraft with only 2 passenger seats and then lots of extra space for transporting goods. With regard to cargo or some other applications, yes, we absolutely could look into that. It's not as obvious what the benefit would be because essentially moving people is like the highest value cargo that there is, and there's no lower certification bar if you're flying cargo versus people. So certainly we've had conversations with large logistics groups and transportation companies in the US. Something could make sense for some niche markets there, but that's not a primary focus of ours.
Next question, again anonymous. Which of the companies is closer to FAA certification? Archer, Joby, Wisk? EHang got approval in China some weeks ago. What is your opinion on EHang?
Yeah, it's a great question. So I'm obviously biased, but I'll just give you the objective data, and then you can make your own conclusions. So my perspective is, the FAA, EASA, maybe you could add Transport Canada, maybe you add ANAC. Those are the real aviation regulators globally that everybody trusts. So if you look at those groups and then try and measure who's the furthest along, in the United States with the FAA, there's only 2 companies that have their airworthiness criteria published in the Federal Register. You can actually go online and read ours. The only other group that has that is Joby. So just from an objective perspective, we're about at the same point as Joby. We think the key differentiator for us is we've chosen this much lower risk path where we're partnered with companies like yourselves, we're partnered with other leading groups, leveraging anywhere possible existing components with certification heritage, the data, et cetera. So we're optimistic and hopeful that will pave a much more efficient path to market for us than our biggest competitor, who's taken essentially the opposite approach, which is to develop everything in-house, completely vertically integrated, push every technology bit forward. So again, we view the decision just through hey, what makes sense for the business? Does that actually make the business more compelling? And for everything we've seen, the answer is no. EHang in China, I think that's fantastic. I think this is an industry that just needs more successful players. I think, again, over time, there's going to be lots of infrastructure needed, lots of support from governments. So I'm super happy to see other companies out there pushing forward and being successful.
Right. Well, fortunately, there's not only one car brand on the market, but several. Next question from Valentin. When comparing the New York routes you have shown, how does the energy consumption compare? Car, public, Archer?
Yeah, that's a great question. So if you look at it from a pure energy perspective, on a per seat mile basis, our aircraft uses slightly more. It's almost twice the energy as a very efficient electric car for the same distance. And that's just purely physics because we fly much faster. And so drag goes with speed squared. So if you fly faster, it just consumes more energy. So obviously, if you compare to public transit where you've got very high utilization, so you have trains full of people, really tough to compete with that. But We think there's a great niche or early market here where, again, we're able to deliver the service at a competitive price in a sustainable way because it's, you know, zero local emissions, and then be part of the future transportation ecosystem. So I don't think that in the very near term, every trip that somebody's going to be doing will make sense to use a vehicle like this. I think if you look forward 10, 20 years, I think there will be many trips that make sense. And I think it's very likely that cities end up changing. And just as now people live in suburbs and drive for 30 minutes, maybe say, so I live in San Francisco Bay Area. I prioritize, you know, living close to work because I have 2 little kids at home and I like to spend time with them. But I would also love to live at the beach, which is actually not too far if you just drew a line. But the problem is there's mountains in the way. So practically speaking, it would be an hour-and-a-half drive each way every day. And so it's something I would never sign up to because of what I prioritize. But if I could do that same trip with a vehicle like this in 10, 15 minutes, the same as my drive would be today, wow, that would totally change how I, you know, could potentially live my life. It could actually change how the cities are designed. It could change real estate values. It could have all these really interesting knock-on effects. But still, it won't be the only source, right? I'll still walk to the store or ride my bike to visit a friend, you know, take the train when I need to take the train in a city where the infrastructure is good. So it's just all about providing more options and giving people the flexibility to choose how they move around the places that they live.
So let's hope the short sellers will move from eVTOLs to the real estate with the increasing improvement of the whole industry. Yeah. Next question from Joanna. For an airport, you need big surfaces for all the planes. How you will solve this problem in the middle of the big cities?
So we really intentionally designed the aircraft to have a very light infrastructure footprint. So the wingspan of the aircraft is just under 50 feet, so whatever that is, 15, 16 meters, something like this. And that's about what existing helicopter infrastructure is designed for. So the concept of operations is you would land on a piece of real estate that has that sort of final approach and takeoff area. If you're familiar with helicopter lingo, it's called the FADO. And then there's obviously a safety buffer around that. But then you could imagine taxiing the aircraft off to a stand where there's charging infrastructure, and then doing the people on and off, quick cleaning of the airplane, turn it around, etc. It really doesn't require that much in terms of space or complex infrastructure, etc. The aircraft themselves don't weigh much more than a large automobile, so there's no significant impact loads or downwash loads to these pieces of infrastructure. One of our partners is a company called Reef that operates a very high percentage of the parking garages in the United States, actually more than just the United States. And there's an interesting synergy there where if you think about these big parking structures in metropolitan areas, nobody wants to park on the very top surface because they want the shade, driving their car underneath. And so often there's these huge spaces that are just sitting there unused. So you could imagine converting those spaces into infrastructure for these sorts of aircraft, and you can actually get quite high utilization, like many thousands of people per hour out of something like a typical typical large-scale parking garage. So again, I think it'll be step by step. Early days, that probably won't exist because of the regulatory needs, and we're going to need to prove that the vehicles are safe, and people are going to have to accept them into their neighborhoods and things. But then over time, who knows? You could see, again, from a real estate perspective, it being very compelling to live in, say, a complex that has access to this sort of infrastructure. So we've got another one of the larger real estate groups in the US keeps coming to us wanting to incorporate these vertiport type structures into their construction projects for big developments they're doing across the country. So it'll be interesting to see how this all plays out over time.
Right, that's a game changer. I mean, thinking about what it does to real estate when you build an underground there, for example, which costs you millions or billions, and with eVTOLs you can have an on-demand connection to the major mobility hubs. So quite interesting. Maybe the short seller will move away from both areas because also real estate might have a rise in that. Next one from Anonymous. How does the order book look like today? How many confirmed orders are placed?
So the only orders we've announced publicly are with United. So they have an order of 200 aircraft with an option for another 100. So the value of that order is something like $1.5 billion, and it'll take us many years to deliver against that. We also announced a MOU with a company called Interglobe, which is the parent company of Indigo Airlines. It's the largest airline in India by passenger volume. So we don't have a firm order from them yet, but we're working towards an order for them as well. India is a super compelling follow-on operating market because the infrastructure is so challenged and the population density is so high. It's like the most distilled kind of ideal use case, let's say, for aircraft like ours.
Right. How does the concept of the battery work? Is a reload necessary after every flight? Is it possible to switch the battery, empty one out, full one in?
So the batteries are designed to be recharged very quickly between each flight. And the reason that's possible is because we have relatively high power demands in takeoff, so the batteries are able to accept higher charge than, say, a typical car. The challenge is keeping them in a temperature range that supports the long life and many cycles. So the way this works is after the aircraft lands, it's connected to both a charger and battery cooling or heating unit. And so coolant is circulated through the battery pack with ground-based infrastructure, and that either warms the batteries up if it's very cold outside, or cools them down if you're operating in a high-temperature environment. So we do not plan on swapping batteries between each flight. Like I mentioned before, the batteries make up a huge fraction of the weight of the aircraft. So if you think about the practicalities of in our case, the redundancy that I mentioned, we actually have 6 high voltage batteries on board the aircraft. So you'd be swapping 6 components that each weigh something like 300 pounds. Tough to imagine that being like an efficient kind of everyday operation. But the other thing to keep in mind is the use case is very high utilization of the aircraft. That's actually how we're able to get the ticket prices down. And so in order to get the utilization up, we're putting lots and lots of cycles every day on the vehicles. So it won't be 1 or 2 flights per day like you might fly a helicopter, but it'll be more like 20 or 30 flights per day. So that means after maybe 6 months of usage, the batteries will have degraded, and so we need to be able to perform the maintenance on the aircraft quite efficiently, such that in just a few hours, say overnight, the aircraft can be have the batteries replaced with fresh units.
Next question from Anonymous. The US military recently invested into Archer. What use cases for the military do you see or are planned to have in that field?
Yeah, it's really fascinating talking to the Department of Defense about this. So our primary contact is with the Air Force, and what most people don't realize is in the US, the Air Force is really a logistics company. So they're responsible for moving all the people and goods all around to just make the machine work, if you will. And so much of what they do is dependent on fuel, moving fuel around, burning fuel to move goods around. And when they look at how they're doing that today, there's this really interesting niche where if you think about needing to get, say, a high-value part from one side of a facility to another, or from one location to another in a relatively short distance, their only option is to fly a helicopter that costs $5,000–$10,000 an hour to operate and burns a tremendous amount of jet fuel in the process. So the U.S. DoD has very strong sustainability goals. They want to, as much as possible, reduce their carbon footprint and save money. Like they know it's a waste to fly a Black Hawk 50 miles with a washer to make another airplane work. So they're super interested in these aircraft for those logistics missions. So if you imagine, hey, I need to get somebody out to go repair an aircraft or deliver a critical part or do a short, offshore to ground type mission, that's what they think is super interesting. Our own kind of perspective on this is the aircraft aren't super valuable for, call them more pure military type uses, in terms of fighting or things like this. The aircraft just don't have the capability. The range is limited. They're quite small. They're much more useful for these logistics type missions. So that's everything that we're focused on.
Guys, if you want to give Tom a short break, you should upload questions for other panelists as well.
These are great questions. Enjoying it. Yeah.
Next one from Andreas. How do you plan the training for pilots?
Yeah, so this is a really great one. Couple ways to think about that. One is there's a regulatory piece. So obviously the FAA governs the requirements for pilot training, and that's done in a few different ways. One is the broader operational construct. So when we talk about operating these aircraft, we will need our own, or the operator will need a certificate in the same way that an airline does. So our service is classified as on demand, meaning we don't have pre-scheduled, you're on flight number 123 from these points. It's, I have this customer demand. Okay, I will generate a flight to serve that demand. So there's established rules in place for pilot qualifications for that sort of an operation. But what doesn't exist are the qualifications for the specific aircraft. So we are classified as a powered lift vehicle in the US, and there's no pilot training requirements today for that category. The FAA has published draft requirements for that, and I mentioned earlier, those final requirements are on track to be published before the end of next year, so in time to support our entry into market. But if you go read that document, what you'll find in there is that the training for our aircraft will essentially be type rating. You'll need a type rating in the aircraft, just like you would for any other large aircraft or turbine aircraft. And then the question is, okay, if you need that type rating, how does that scale? So if we need thousands of pilots, do you need thousands of level D flight simulators like you would if you were going to fly A320 or 737? And so that's where the answer gets a little more interesting, and that's because we are being forward-leaning in our approach towards making training efficient and safe. So we don't think it makes sense to invest $10 million into a level D sim to fly a $4 or $5 million aircraft. Like that's the math doesn't really work there. The other thing is the aircraft are quite simple to fly. So while they're absolutely piloted, the pilots are just providing pretty high-level guidance. So if you were to come fly the aircraft, one of our simulators, to take off, you basically just pull back on the right stick and the aircraft will lift into a hover. If you let go, the aircraft just hovers in place with the sensors and computers and software it has on board. So that kind of changes the type of training that matters to get a pilot to be safe and qualified. It's much more of a, how do I manage the aircraft through its flight profile? How do I manage the emergency procedures? So this is actually a big area of collaboration that we have with DoD as well as the FAA. So another factor here is our aircraft is a single pilot. So it's not like a traditional, you sit next to the instructor and you go out and, you fly circles around the sky and you learn. And the DoD has the most experience in training pilots for aircraft like this because there are not as many civil single place aircraft. So we are working to deliver a simulator that will be quite high fidelity through the use of augmented reality, as well as much more affordable. So instead of something that will cost $10, $15 million, something that will cost $1 million. And we'll be able to give people the bulk of the experience they need to become qualified, safe pilots to train.
I think we should push Microsoft together to integrate the Midnight into the Microsoft Flight Simulator so we can try it out at home on our Xbox and our PC as well. That would be awesome. And I can't believe the guys are listening to me because the next question is for Robert. Robert, what is FACC's USP in your opinion for eVTOL serial products?
I would bring it down to three factors. 35 years of composite experience. That's what I think Tom mentioned. It's lightweight. That's what you need on those airplanes. Then it's turnkey. We can engineer, we can produce tools. We have a production system, we have a quality system, and we have a global network supporting our customers. And the third, looking a little bit ahead, it's strong R&D, innovating new materials, processes to fulfill the future expectations of our customers. So that's what we can bring to the table, and I think that's what our customers are appreciating.
Next question from Diego. Have you thought about hybrid propulsion systems as range extenders?
So like I was talking about earlier with the fuel cells, yes, absolutely. It essentially comes back to what markets do we want to serve. So again, the strategy is go to market battery all electric, focused on short routes. But if we were to find out that, say, there was a strong market for longer range flights, we certainly could develop a hybrid version that would require still a high power battery on board for takeoff and landing, but then some, hydrocarbon or other fuel-based range extender to go further. Certainly technically possible, just not on our business path today.
What do you think from an engineering standpoint? That's a good idea?
Range extender is always a great idea,
And,
be it whatever technology you choose.
and what about you, Günther? Joking. Which one do you know?
I very much appreciate the approach from Archer, that they have selected the first operations in doing the commuting flights between the airports, for instance, because we don't come into that field that we have to wait for the next technology step in increasing the energy densities, things like that. They're using a very sophisticated technology, but technology which is already available. So, and that takes again down all the uncertainties of that new product. So I would say step by step, and we fully have understood of all the presentation from Tom and all the information we get from customers, that there's enough market also for the short range. That would be something different in regard to electrical flight for bigger aircrafts. Then you come into that field. But for the starting point, there are enough applications, enough market opportunities using, at least in this field, an existing technology.
I think here is the specialist, and you said it before, Tom. I think urban air mobility is urban. I think not too many people are going city to city. First of all, you don't have the mass of people you can transport between Vienna and Munich. It's only 4, and then you fly. And if you fly today in super bad weather, shaking around, maybe that's not the most convenient experience passengers might have. So range extenders are adding weight, and if you don't need the range, you shall not put the weight on the airplane.
Yeah, and that is really backed up by the data that we have. So like I mentioned earlier, we're super analytical in our approach to this. So we actually have data that shows how people move around all the major cities. And you can just look and see, how big is the demand if you're out at the longer distances. And you see this very clear peak that is a maximum of around 15 or 20 miles, and then tapers off very dramatically around 50 miles. So we could be wrong, or people could change, and actually there would be demand, but right now we're very confident in the strategy.
I would wish for a B2B commercial product where you as a corporation can order a vertiport solution together with a Midnight, and then you can establish routes on demand as a company as it would suit you. In our case, maybe Airport Munich, we have to drive a lot there, or in my case, I would love Linz because I have to drive that every day. However, I think that's a great thing to have, maybe inspired by Airbus, who have a shuttle in between Toulouse and Hamburg with an aircraft, but to have that available for an affordable price for every company. That would be an amazing product. Next question from Thomas. how much power your battery packs will have and how much kilowatt hours is required per typical flight. And reminder, guys, T-4 minutes. We need to stop sharp today at 7 because the guys have to catch another meeting.
Yeah, I love the technical questions. This is great. So in hover, Midnight uses about 750 kilowatts. That's the power required to hover. In forward flight, it drops dramatically. So it's closer to 150 kilowatts. The battery on the aircraft is around 140 or 150 kilowatt hours. And so in an average flight where you're flying maybe 15, 20 miles, you use something like 1/3 of the energy on board. So 50 kilowatt hours, something like this.
Next question is for Günther. Will there be a plant only for UAM in the near future?
I don't think that there's a plant only for UAM, but what we will do is to expand our global footprint, our local for local approach. So that's an option, but it's not the only option. So we will figure out the next couple of months what kind of setup is the right one
So
for
maybe
all of
not.
our products and for our local for local approach.
So maybe not in the near future, but when there is scale.
The scale and maybe, as we heard a lot of today, maybe technology is changing, and then UAM needs another technology than the traditional customers. Why not? But it's too close for the near future, when near future is 1 or 2 years.
Right.
I'm pretty sure that we have to be closer to the customers. So in that extent, it's yes. It must not be necessarily just for UAM. It can be also, again, a combination. The technologies we are considering for the low rate, moderate rates is very comparable in regard to the production equipment we are using with the parts we are producing for our traditional established customers.
Next question. Does the FAA intervene in the development process of Archer Midnight? How do you assess their influence, neutral, constructive, or concerns raising?
So the FAA's approach is everything is about safety, right? And so all the requirements that they flow down to us are from their perspective, trying to make both the people on the aircraft and the people on the ground safe. So that's the intent of everything. The way they do that, though, is very high level. So they'll never tell you how to design something. They'll just tell you what the safety objectives are. And they'll expect you to come with, hey, here's my solution, and here's why I think it's safe and meets the intent. So that's kind of how the process works high level. How is it going? Are they intervening? They're being quite reasonable, I would say. Again, there's a good environment in the US to make this happen. And that's really necessary because the flip side of the coin is, well, what's the safest thing to do? It's to do nothing new, right? If the FAA says no, that will always be the safest solution. But we know to progress the industry, the world, we can't just say no, right? We need progress. So having the momentum and political environment is essential to get the FAA to say yes.
Right. Well, it's great to see more and more questions incoming, but I suggest we take the last two, since we need to close on time, and I see a lot of hungry faces already, and a few guys want a beer. So your last chance to upvote. Next question is, if you are building your own plant, does it mean you will build your own components in-house, or is it going to be mostly an assembly facility?
So the plant you saw in Georgia that we're building, that's final assembly and flight test facility. We are, though, building our own electric engines. That's what we call the motors and inverters, and the battery packs. So our production lines for those components are located in California today. They'll likely stay in California for the next couple years before we really need to scale them up. But other than those two subcomponents, everything else is sourced from the supply base.
Okay, now it's very difficult. You voted 4 questions, or 3 questions, and all have 4 upvotes. So we stick with the first one, or you want to choose one? Let the engineering choose. We take the last one? How much will one aircraft cost?
So the only data we've announced there is the contract with United. So that was done at a $5 million average selling price. But the interesting thing to keep in mind is, we're not planning to sell the aircraft to any individuals. And so what really matters is the ticket price. And the kind of surprising thing there is if you do the math and you add up all of the direct and indirect costs, that aircraft kind of capital investment piece is actually a small contributor to the total cost. It's really more things like the infrastructure cost, the pilot cost, the maintenance cost, the battery replacement. Those are the strong drivers. So that ticket price is not super sensitive, at least at the scales that we're talking today, to that average aircraft selling price.
Well, all good things come to an end, and so does the last Flight Club edition of this year. Thank you very much to all panelists, especially thank you to our friends from Archer for coming. Thank you to you, Tom. I think in the next week we all are going to enjoy the year-end race, so it's good to enjoy this evening now. And I hope in the not too distant future we'll soon have the opportunity to see an Archer Midnight in Austria, maybe even flying in Austria, and I can't wait for that.
It'd be fantastic, and you're always welcome in California to come see a flight test, and it'll be a great moment when we fly with the aircraft that you're building with the pilot on board, so can't wait for that next year. And thanks to everybody for all the questions too. I really enjoyed the conversation. And I want to make a shout out to Taylor from our team in the back there. He's been here for many months, so thanks Taylor for moving to Austria for Archer.
It's the best country you can live, except San Diego.
I think that's a nice words to end. Thank you very much. Applause to you.
Hey, thank you.
Thank you very much, Clark. Thank you.
Really good.
Thank you very much.
Hold on 1 second.
We take a picture together, and F&B is open. Food and beverage for everybody.
To this.